The internal combustion engine is the most widely used engine in the automotive industry. It's reliable, inexpensive, and it all starts with just the turn of a key or the touch of a button. Whether it's gasoline or diesel, internal combustion engines contain thousands of moving parts, all coordinated to operate at peak efficiency. Tighter tolerances, higher pressures and temperatures, and ultra-precise computer-controlled injector timing all make these engines faster, more powerful, and much more efficient than their predecessors. However, the combination of these engineering developments also makes these vehicles vulnerable to carbon deposits. Just a small amount of carbon, anywhere from inside the injectors to the end of the emission system, can cause a noticeable decline in performance. Because of this, preventive maintenance is even more important in today's internal combustion engines. Oil loss is at the forefront of engine problems today and spans across all three engine types. So what's causing oil loss? Thinner oil, extended oil change intervals, and engine designs. Today's lower oil viscosity blends aid in less resistance between the engine's moving components to help increase fuel efficiency. However, these thinner oils can result in oil loss by evaporation. The current API category standard for gasoline engines allows up to 15% oil volume loss per NOACK volatility testing, while for the most part, ACEA category oils allow up to 13% oil evaporation. For diesels, CK4 FA4 has a maximum limit of 13% loss. Oil vapors enter into the PCV or CCV in diesels, causing sticky deposits to form in the intake and on the valve stems and obstruct the incoming air. Extending service beyond an oil's capability to protect encourages sludge, varnish, and carbon deposits. These three detriments decrease the integrity of the engine and cause component wear. Then, wear allows oil to be consumed in the combustion process. One new engine design innovation that contributes to oil loss is low-tension piston rings. Reduction in piston drag allows for easier engine rotation and better fuel efficiency. But these rings are also highly vulnerable to carbon deposits. Even the smallest amount of carbon can cause rings to stick, which allows a large volume of cylinder compression to escape. This contributes to fuel dilution and elevated crankcase pressure. As a result, oil droplets are pushed through the PCV and lay on components in the intake and combustion chamber and can cause carbon packing in diesel engines. The process of combustion then carbonizes oil deposits on piston tops and combustion chamber surfaces. The hard deposits can lead to misfire, low-speed pre-ignition, poor fuel economy, and a noticeable drop in performance. In the hottest parts of the combustion chamber, injectors are constantly exposed to damaging heat and extreme pressure. It's only a matter of time before injectors plug with carbon deposits and misfire. Without the injector spraying fuel cleaner in the intake like port fuel injected engines, carbon builds more rapidly in the intake ports and on the backs of intake valves. Then, incoming air bakes deposits dry, eventually choking the air supply, and fuel cleaner cannot reach the backs of air intake valves. Gasoline direct injection engines, or GDI, are prone to early carbon buildup. Drop in power and performance sometimes occurs before the first oil change. Diesel fuel is notorious for instability. Without adequate fuel stability to control deposit formation, diesel engines are extremely sensitive to fuel degradation. Fuel breakdown byproducts impede injection and increase deposit buildup, leading to heavy exhaust emissions and power loss. In newer high-pressure common rail or HPCR fuel delivery systems, High temperatures and pressures can cause diesel fuel to break down into carbon deposits more quickly. Internal diesel injector deposits are common in HPCR. The result is poor performance and potential engine damage. Current diesel fuel system cleaners remove deposits from the injector tip, but fail to reach inside the injector itself. BG245 removes and dissolves deposits from the entire diesel injection system, including inside fuel injectors and combustion chambers. A consequence of oil burning in the combustion chamber is that combustion byproducts will pass through the exhaust and deposit in the emission system. For gasoline engines, that means possible catalytic converter damage. For diesel engines, particulate matter, or soot, accumulates in the intricate after-treatment emission system, including the selective catalyst reduction, diesel oxidation catalyst, and the diesel particulate filter. When soot builds up in the DPF, it triggers regeneration, which burns off the soot. Too much soot causes frequent regen cycles. Regen cycles use a lot of fuel and can decrease efficiency and even cause DPF failure. Prevention with the BG Performance Oil Change is the best cure for both gasoline and diesel engines of all sizes. For port fuel and gasoline direct injection engines, this service includes BG EPR, Engine Performance Restoration, BG Extended Life MOA, and BG 44K. For diesel engines, the BG Diesel Performance Oil Service includes BG EPR, BG DOC Diesel Oil Conditioner, and BG 245 Premium Diesel Fuel System Cleaner. Routine maintenance with the BG Performance Oil Change will restore power and fuel efficiency, reduce harmful emissions, and prevent excessive oil loss.